Hey all, those are the second review. This is similar triangles. So the three things we're going to look at in the test are linear and quadratics, similar triangles, and Pythagoras. Those are the three things I'm going to focus on for the test. So, similar triangles are, well, when we say similar, what we mean is it has exactly the same shape, but it's a different size. So slightly bigger, slightly smaller. So if similar triangles, it's the exact same triangle, they've just been dragged out to be bigger or compressed to be smaller. But all the angles are the same and all the sides are basically in the same ratio. If I increase one side, double one side, I'm going to double the other side. How do you tell? Well, three ways. The first is if all three angles are the same in both triangles, they have to be similar. There's no other way. The second is, and this is what we actually use them for, if the sides all have the same ratio. So if you divide the length of the side on the big triangle by the length of the side on the little triangle, for example, 10 divided by 5 is 2. The next one, 12 divided by 6 is also 2. What does that mean? Well, this triangle is twice as big as that triangle. That literally I've doubled the size of this triangle. But it's still the same triangle. The last one is if you know two of the sides have the same ratio and the one angle between them is the same, then it's also going to be similar. So if I know, 12 divided by 6 is 2, 16 divided by 8 is 2, and I know they both have a 40-degree angle, again, that's going to be a similar triangle. Now, to find the side, what you want to do is use that fact that they have to have the same ratio. So the side on the big triangle divided by the little triangle will always be the same. So for these ones, this triangle is 3 times the size of that one. So obviously this isn't drawn to scale. 9 divided by 3 is 3. 12 divided by 4 is 3. So x divided by 5 would also have to be 3. So you could do that and use x divided by 5 as 3, but I find the best way to do this is to always do it as a ratio, because that way it doesn't matter which side you've got, it'll always be the same. So x divided by 5 equals, just pick either of these, 12 divided by 4. Cross multiply, 4 times x equals 5 times 12, which is 60. Then divide by the number in front of the x, and you'll get an answer. This will always work, okay? If you set it up like this, side on the big triangle divided by side on the little is side on the big divided by side on the little. Cross multiply, then divide by the number. You will always get the right answer, even if you're missing more than one side. Even if the thing you're solving for is on the small triangle, it would be on the denominator. It would be a little tricky. This always works. All I can do is change the numbers. It's always going to be exactly the same math. The best example of this is what we call the shadow problems, where if you have, for example, a 6-foot boy with a shadow of 10 feet and a flagpole with a shadow of 85 feet, you want to know how tall the flagpole is? Exactly the same. The height of the flagpole divided by the height of the boy, so big triangle, little triangle, must be the length of the big triangle divided by the length of the little triangle. Cross multiply, 10 times x is 85 times 6, does 510, divide it by the 10 in front of the x, and you get 51 feet. So you'll always get the right answer if you do it like this. And that's really, as I said, the key to math, is not trying to do it all in your head, realizing that I can only ask you one question, and it's always exactly the same. All right, by the way, the reason this is a similar triangle is we know this angle is the same, and because the shadow of the sun's always at the same angle, we know and we know the sides. All right, that's it. See you in a bit.